Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, geometric sequences. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 4 parts, so leave a like, smash subscribe, and let's get started. On this channel, we've already covered arithmetic sequences, and if you've been following along with me recently, you will see something very familiar in today's video when we're covering geometric sequences. And that's because our geometric sequences will have a lot of the same nuances as our arithmetic sequences. But if you hadn't seen that video on arithmetic sequences, and if you're not familiar with arithmetic sequences, no worries. You can find it right up here. But for today's video, I'll be giving a quick recap of our arithmetic sequences so we have a starting point when we start drawing comparisons between the two. So let's jump into this first sequence here. This is going to be an arithmetic sequence, and we know that because to get from one element to the next, we're going to be adding a fixed 5. A fixed 5 takes us from one element to the next in this sequence, thus making this an arithmetic sequence. And the notation we used for this was D, the difference or distance between any two consecutive terms, is going to be 5. And we talked about how our arithmetic sequences have both an explicit and a recursive formula. And we wrote those to be a sub n, so our explicit a sub n is going to be our a sub 1 plus our d times n minus 1. Now we talked about this n minus 1, and that's because to get to any particular n, so in this case we have our notation a sub 4, a sub 3, a sub 2, and a sub 1. To get to any particular n, or a sub n, we're going to have to add our d, our difference or distance, n minus 1 times. So if we want to get to 4, we're going to add 5 3 times. If we want to get to 3, we're going to add 5 2 times. So you see it's always going to be adding the d one less than the number that we're looking for. That's how we developed our explicit formula. And our recursive formula is going to be even easier than that. So we wrote that as, we need an a sub 1, that was going to be some number k, and our a sub n is going to equal a sub n minus 1 plus that same k. So if you have an element, let's say a sub 3, if you're trying to find a sub 4, all you have to do is take your a sub 3 and add your d, your 5 to it, and that's how you would get your recursive formula. This is all we covered in that video that I talked about. However, for our geometric sequence, we're going to be looking at the same type of components here, but there's just one main difference, and that's going to be how our pattern is constructed. Now, if we try to do the same thing here, notice that to get from here to here, you have to, let's say, subtract 2, right? To get from here to here, we can't subtract 2. Because that's not going to give us our next term. So this is definitely not an arithmetic sequence. However, there is a pattern here. We don't want to ignore this and say that there's no pattern just because it's not an arithmetic sequence. There is a pattern here. And you can think of this pattern in one of two ways, as a multiplier pattern or a ratio pattern. Now, for your textbooks, you may come into ratio a bit more, but whatever one makes sense for you to grasp the situation, use that. So if multiplier just kind of makes more sense, use it. If ratios make more sense, use it. Just know they're talking about the same thing. But I will discuss both of them so you can see. So we're going to cover multiplier first. Now, if we were to try to find our pattern using the idea of a multiplier, what we multiply by to get our next term. So if we're starting here, what are we multiplying by to get a negative 4 when we're starting at negative 2? Well, it's going to be multiplied by 2, right? Multiplied by 2. Let me clean that up a little bit for us so you can see. We're multiplying by 2. Here we're adding by 5. Here we're going to be multiplying by 2, right? Because even going from negative 4 to negative 8, we're going to do the same multiplication by 2. Negative 8 to negative 16 our same multiplication by 2. So the way we construct our pattern is going to be similar, just a little different. Instead of adding the same number, we're going to be multiplying the same number. And this is going to be if you look at your pattern as a multiplier. But what if you look at your pattern as a ratio? So we're going to write the same thing, -2, -4, -8, -16, dot, 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 dot. If you look at your pattern as a ratio instead of a multiplier, what you do is instead look at the ratio between your consecutive terms. So -4 over -2. This is going to be -8 over a -4. This is going to be a -16 over a -8. If you were to simplify all of these, you see that you get 2, 2, 2. You have a consistent ratio between any two consecutive terms. So whether you find a common multiple or a common ratio, you're going to be doing the same thing. Just use the one that makes more sense to you. Now that we talked about finding our patterns for our geometric sequence and compared it to how we did it for our arithmetic sequence, let's move on to some notations and formulas. Here we have a D for the difference or distance between the two terms. Instead, for your geometric sequence, you're going to be denoting that by an R. And that's because most textbooks are probably going to have this as a ratio. So your R is going to be a ratio. So for this case, it's going to be R equals 2. And just like for your arithmetic sequence, you're going to have an explicit formula and a recursive formula. Your explicit formula is going to look pretty similar. You're going to have a sub n is going to equal a sub 1. So we have a lot of the same characters. Instead, you're going to have your R to the n minus 1 power. This is going to be our explicit formula. And your recursive is going to look pretty similar as well. You have your a sub 1 equals some number k, and your a sub n equals your a sub n minus 1 times your R. So notice there's a lot of similarities between your arithmetic sequences and your geometric sequence. However, there are some key differences in why they're both two different sequences. But let's move on to our next part of the video in which we're going to find our explicit formula from a geometric sequence. Now, we want to derive this. I'm going to tell you how this makes sense and why it makes sense. So let's revisit the sequence that we just covered in our previous section, -2, -4, -8, -16, and so forth. We already know that this is going to be a geometric sequence, and we want to find our explicit formula and figure out why it makes sense the way it looks. So the first thing we do is put our R's here. Now we already talked about this. This is going to be, therefore our R is going to be 2. And I'll even put our explicit formula here so we can kind of see where we're trying to end up. But let's take it step by step. Let's say we add a sub 1, and we know that to be our -2. If we want to go to a sub 2, we're saying that we're starting at a sub 1, and we're going to multiply 2. So if we want to go to a sub 3, we would start at a sub 1. Remember, this is our explicit formula. We always start at your first term. A sub 1, and we're going to multiply times 2, multiply times 2 again, and we're going to get to a sub 3. If we want to go to a sub 4, we would have -2 from our a sub 1 times 2 times 2 times 2. So now that we have it written like this, let's rewrite this in a way that is going to give us something like this. So we can actually write this -2 as -2 times 2 to the 0 power. We can write this as -2 times 2 to the first power. We can write this as -2 times 2 to the second power. And we can write this as -2 times 2 to the third power. And that's because we have 3 here, we have 2 here, we only have 1 here, and we have nothing here. So our exponent is going to be how many 2's we're going to be multiplying. But notice that the number of 2's that we're multiplying in this case, 3, is going to be 1 less than the term that we're looking for, our a sub 4. And that's going to be true for all of these. When you add a sub 3, your exponent is going to be 2. When you're looking for a sub 2, your exponent is going to be 1. And when you have your a sub 1, you're going to have an exponent of 0. Therefore, our formula here should make sense. you're starting at a sub 1, and you're going to multiply whatever your r is, whatever your ratio is, n minus 1 times. So knowing this, we can actually create our explicit formula for this sequence. Now that we know how it makes sense, this is going to be our a sub n, our general formula, our general explicit formula for our sequence is going to be a sub 1. In this case, we know a sub 1 to be a negative 2. So a negative 2 times our r, which is going to be 2 to the n minus 1 power. Let's move on and spend a little bit of time talking about our recursive formula now. We're going to be using the same sequence, and we're going to generate our recursive formula and talk about why it makes sense. So we already know this is going to be times 2 times 2 times 2. And if you already had all this, you can easily create your recursive formula because your a sub 1 is going to be this here. And we know our a sub n is going to be a sub n minus 1 times our r. So our r in this case was 2. You can easily write this, but why does this make sense? Well, let's look at it. Let's look at it for a quick moment here. When we have a sub 1, which is going to be our negative 2, let's rewrite this a little bit out. So we have a sub 1 equals a negative 2. If we're trying to find our a sub 2, this is going to look very similar to our explicit because it's our first term outside of our actual first term. It's the first term we're trying to find. So it's going to be our negative 2 times our r, which is 2, right? Our a sub 3, if we're starting here, because we know this is going to be a negative 4, if we're starting here, it's going to be a negative 4 times 2 again, right? We're going to keep going to get a negative 8. A sub 4, we're going to take what we had, negative 8 times 2 again, and we're going to get our negative 16. So just like our recursive formula worked for our arithmetic sequence, it's going to work in a very similar fashion. We just have a formula that's a little bit different than what we had previously. But the feel should be pretty similar to what we are already used to with our arithmetic sequence. Instead of adding by our d, we're going to be multiplying by our r. That is the main difference for our recursive formula. So going back, your a sub 1 in this case is going to be a negative 2. And your a sub n equals your a sub n minus 1 times whatever your r is. In this case is going to be 2. This is going to be your recursive formula for this particular sequence. Now that we've talked about our explicit formula and our recursive formula, let's jump into an example in which we can find both of them for a new sequence. So in this example, we have the sequence negative 1, 6, negative 36, 216, etc. Keep going. We want to find our explicit formula and our recursive formula for this sequence. Now, this should be a geometric sequence, and you can easily test that by finding your common multiple or your common ratio between your consecutive terms. So we're going to start with that. We're going to start at negative 1 and go to 6 and figure out what is going to be our common multiple or our ratio for this sequence. I'm going to use the idea of a multiplier. So going from negative 1 to 6, what are we multiplying by to get that? So if we did negative 1 to 6, we would have a negative 6 here. So we're going to multiply by a negative 6. If we're going from 6 to 36, we're going to multiply by a negative 6. And going from negative 36 to 216, we're once again going to multiply by a negative 6. So this indeed is a geometric sequence, not an arithmetic sequence and not some other type of sequence. This is geometric because it's going to be the same multiplier throughout, or it's going to have a common ratio between any two consecutive terms. So now we know that our r is going to be negative 6. Let's get to writing our explicit formula. Now we know that we're going to be starting with this. A sub n equals a sub 1 times r to the n minus first power. So all we have to do is plug and chug. We have our a sub n equals our a sub 1, which is going to be, in this case, negative 1, times our r, which is going to be a negative 6. So put that in parentheses, to the n minus first power. And you don't need to simplify this any more than that. You can leave this just as it is. Now let's move on to our recursive formula, which is probably going to be even easier. We're going to have our recursive formula, so our a sub 1 is going to be our -1, and our a sub n equals a sub n minus 1 times our -6, because we're having to do our general formula. A sub 1 equals some k, and our a sub n equals some a sub n minus 1 times our r. We started here, and because we have this sequence, this is what our recursive formula is going to look like. So I hope you were able to follow along with today's video, and you now know your geometric sequence is going to look very similar to your arithmetic sequences. However, if you have any questions about what you saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope you help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.